Hello, and welcome to Tech to Tech presented by Kaizen, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce Kaizen's own Wayne Raney.
Thanks, William. And I'd like to thank everyone for your time. Today, we're going to be talking about the Conductivity Control System made by Kaizen. We'll try to help solve incorrect readings and a high chemistry consumption at a customer. The CCS is a Kaizen-made system which is used to regulate the concentration of an aqueous cleaning chemistry. The concentration can be determined by measuring the conductivity of the fluid. The picture on the right is the system, and the picture on the left is a system above a drum. When the conductivity goes below the set point, then the system will add chemistry with the yellow LMI pump. When the set point is reached, the addition is effectively stopped. The chemistry we're going to be talking about for this particular customer is Kaiser's METALNOX 6319 CP. This chemistry cleans the parts in the wash tank at one set point. It also provides corrosion protection in the rinse tank at another set point. So this chemistry requires two separate conductivity control systems, one for each tank. We had previously installed two CCSs, one on the wash and one on the rinse tank, but they are having problems of inconsistent readings and high chemistry consumption. Before our visit, we decided to do a couple of things while we were there, including a calibration check, changing the probes from a dip and tank style to an inline style, and adding a system idle function. We hope this helps the inconsistent readings and the high chemistry consumption. This is what the sensors looked like before we changed them. These are the dip and tank style sensors, and we had a theory that they were not measuring a well mixed sample of the chemistry. Essentially, they were in dead areas. We plan on changing these to an inline sensor, which will measure a well mixed concentration coming directly off the wash pump and directly off of the rinse pump. The first thing we want to do is a calibration check. This is the calibration check procedure in the CCS operation manual. If the calibration check is out of spec, then you can clean the probes and perform the calibration check again to see if there's a difference before and after cleaning. This is an example of what a probe looks like before and after cleaning. The probe on the left has a coating on it, and the same probe is pictured on the right after cleaning with IPA. This film can cause a high resistivity, and since the resistivity is the inverse of conductivity, as the resistivity goes up, the conductivity goes down. So this lower conductivity reading can cause your concentration to indicate low, and it'll cause the CCS to add excessive chemistry to try to increase the conductivity to the set point value. Most automotive manufacturers require the NIST certificate of traceability. The picture on the left is a certificate purchased from Myron L, but you can also purchase this from another source such as Oakton. We started by not cleaning the probe and measuring a premixed 8% concentration by weight. The customer said that 8% was their set point. We did a calibration check before we cleaned a probe and compared it to the chart. 4.06 millisiemens was the measurement as indicated by the red arrow, and it's just under 8% concentration as indicated by the yellow highlighted portion. An 8% concentration is supposed to read approximately 4.8 millisiemens. This conductivity is lower than expected, so we cleaned the probe and the conductivity actually came up to the proper value. We also noticed that the customer specification is recorded at 5.5 millisiemens to 9.0 millisiemens. They stated that their spec is 8%. So our calibration check reading was noted to be low, and also their spec needed to be changed. So we cleaned the probe and they went in their preventive maintenance system and changed their specification. Again, the two blue arrows indicate what they had as their upper control limit and lower control limit. Notice that this does not contain their specification of 8%, which again is highlighted in yellow. Next, we performed a calibration check on the rinse tank. With a 3% solution, we measured 1.71 millisiemens. On the control chart, 1.71 millisiemens corresponds to approximately 3% concentration, as indicated by the red arrow. So it seems that the meter and the probe for the rinse tank is actually reading correctly. But the rinse tank specification on their operating instructions is 2.3 millisiemens to 3.5 millisiemens. 2.3 to 3.5 is indicated by the blue arrows. Their 3% concentration spec is indicated by the red arrow. The operating instructions says it should fall between the two blue arrows. So in addition to changing the wash tank spec, the customer also changed the rinse tank spec as well. This was found during the visit. Another thing we did was show the customer how to perform a side-by-side check with a handheld conductivity meter to compare it to the automatic CCS reading. It's recommended to perform a calibration check using the same fluid for the CCS and for the handheld meter. So this is what the inline sensor will look like. We'll mount this on the output of their wash pump instead of the old dip and tank style. This measurement will ensure a proper chemistry sample that is spraying on the actual parts. The problem with installing these probes in this particular customer is that it's a 24/7 operation, and there's a loading robot in our work area. This must be shut down and tagged out before doing any work. Also, we have to work in limited time periods. So we had everything laid out, knew what we had to do to tap off the pump, get flow past the probe, and return it back to the respective tanks. On the right side on this table, we have all the hardware necessary to perform all the work on both the wash tank and the rinse tanks. One thing that we noticed during the work is that their pump out tank has warm chemistry in it. This has to be coming from somewhere, so we'll keep this in mind when we're going in to do the work. We also found a plug which has the ground prong cut off of it, so it's another thing we had to fix. So the first thing we do during one of these maintenance periods is that we plumbed on the output of the wash pump pressure gauge with a valve and tubing, plumbed the tubing to the isolation valves in the sensor. Here's the isolation valves on either side of the sensor. We made this assembly offline and mounted it to the machine in a space where maintenance could be done easily on the probe. So flow entered from the left and exited to the right. This is where we turn the fluid back to from the sensor back to the tank. But before we drilled into the tank, we had to empty them during the 2-hour maintenance shutdown period. These are the empty wash tank and rinse tanks. And when we were emptying the tanks, we noticed something strange inside. This is what we noticed. Water is coming in from to fill the solenoid to the fill solenoid on the left, even though it's not calling for makeup water. The solenoid is stuck open or has trash in it. This causes the level in tank to rise. More fluid is exiting the overflow port. So you can see the level is at the overflow port just to the right of the leaking solenoid. This is how the warm soapy water is getting to the pump out tank during operation. This is like diluting the chemistry tank with water and causing the use of even more chemistry. Here's the video when the machine is completely shut down and de-energized with the tank empty. Again, with this happening, our chemistry is going out the overflow pipe just to the right of where the water is, where you see the water coming in. One more thing that we fixed while we were at this customer is changing the orientation of the connectivity control systems so that they face the operator. We worked with their maintenance personnel and mounted these Bosch railings on the load end of the machine. This provides easy access to the controls. So instead of a probe dipped in a tank as shown in the picture on the left, we mounted the probes directly on the output of the wash pump and directly on the output of the rinse pump in a location easy for maintenance. The picture to the right shows the new setup and location. This helps with proper measurement of the chemistry spraying directly on the parts instead of measuring a possible unmixed area in the tank. Another function we added to help this customer was a cable to the system, which will make the CCS on both the wash tank and rinse tank go into idle mode when the respective pump is off. This will ensure that the system is not adding chemistry when the washer is shut down. This was another one of the theories to the high chemistry usage. The system idle feature required adding a couple relays, one for the wash pump and one for the rinse pump. And we also drew up schematics for the customer's records. So there were several things which helped this customer. We cleaned the probes and calibrated them after they gave us after this they gave us the proper readings. We changed the set points and operating instructions. This gave better clarification. We installed an inline sensor instead of the dip style. This gave steady readings. We found a leaking solenoid. This lowered the this lowered the chemistry consumption over time. We fixed an electric cord and made the system safer. We also added a system idle function, which will help lower chemistry consumption. So the bottom line is sometimes when you go in with a plan, you find other contributing factors to your problems. A few of the commonly asked questions is how often should I clean my connectivity control system probe? Well, if you're performing calibration check and your readings are correct, then you don't really need to clean the probe. But once you start noticing that you need to calibrate the probe after a calibration check, then that'll give you an idea how often to clean the probe. But honestly, I would clean it at least twice a week, regardless. Another question is, does the CCS have automatic temperature compensation? And what about the Octane meter? Well, the answer is both of them have automatic temperature compensation. Third question that comes up quite frequently is my cleaning machine is not a spray and air system. So how can I connect the probe where it will get a good representative sample of the wash solutions? Sometimes your particular system has a recirc pump that we can use, but sometimes we have to add a pump. But you can work with us here at Kaizen to see what is needed to help get a good measurement, and we can also help add a pump to your system if we need to. Last question is, I frequently find that I have an empty drum condition, and it's hard to prime the LMI pump when I connect back to a new drum. Do you offer a system that will tell me when the drum is empty or low? Yes, here at Kaizen, we offer a couple different systems to measure the level in the drum. One is a manual drum level stick, and the other one provides a light tower and alarms when the drum is low or the drum is empty. You can contact us if you would like a quote for one of these systems. But this is all I have for today. I'd like to thank you for your time, and now I'd like to turn it back over to William.
Thank you, Wayne, and thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in this session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who'd benefit from these sessions? The answer is yes. Just go to tech2tech.kaizen.com, fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.